Hello, everyone. Today I'm excited to demonstrate Sentinel LLM, an enterprise-grade SRE observability platform built specifically for production large language model systems. Sentinel LLM solves the black box problem of LLMs by giving teams real-time visibility into latency, cost, quality, and safety, all backed by enterprise observability. I'm now inside Sentinel v3 Enterprise. At the top, you can see the region is us, Central 1. The model provider is Vertex AI, and our observability backend is Datadog running in the US3 site. Before any data flows, I'll initialize the SRE tunnel bridge, which is responsible for securely streaming telemetry from our application into Datadog. I'm clicking Initialize Bridge now. You can see the Sentinel kernel boot sequence complete. Enterprise Datadog credentials are loaded, and a high-resilience tunnel is established to api.us3.datadogq.com. Each metric performs a handshake and receives a 202 accepted response, confirming that Datadog ingestion is live. Now that intake health shows latency, cost, hallucination, and token metrics as synced, I'll move to the load controller and start live traffic using the healthy profile. This simulates normal production usage and begins emitting real inference telemetry. As traffic starts, you can immediately see metrics updating in real time. Average latency is visible in milliseconds. Session cost is increasing as tokens are consumed. Monthly cost forecasting is calculated automatically. Hallucination probability is tracked continuously, and total tokens increment live. I'll now ask the first question in the Sentinel SRE console. What is the current health of the LLM system? The response you see is generated using live telemetry flowing through Datadog. The assistant confirms the system is healthy, latency is stable, error rates are negligible, and there are no high-severity incidents. This response is not static. It is dynamically generated by reasoning over real production metrics. Next, I'll ask why latency changed in the last few minutes. Here, the SRE assistant correlates latency behavior with traffic patterns, throughput changes, and potential configuration or infrastructure factors. This demonstrates how Sentinel LLM connects raw telemetry to operational reasoning, instead of just showing charts. Now I'll introduce stress by switching the load controller to spike mode. As soon as this happens, latency increases and hallucination scores rise. These signals are immediately ingested into Datadog and reflected back into Sentinel LLM. In the fleet incident feed, you can see detection rules firing. Rule 1 detects a performance SLA breach when latency exceeds 2 seconds. Rule 2 detects AI quality drift when hallucination scores cross the configured threshold. I'll click Generate SRE Insights for the AI quality drift incident. Sentinel LLM now performs automated root cause analysis using a Gemini supervisor model. It explains why the hallucination score crossed the threshold and generates a clear 3-step runbook that an engineer can act on immediately, such as reviewing inference logs, rolling back prompt changes, or adjusting model parameters. Next, I'll ask another operational question. Are we spending more than usual on LLM calls? The assistant explains that increased spend is typically driven by token volume, request rate, or model tier changes, and recommends comparing current usage against historical baselines. This reasoning is grounded directly in our live cost and token metrics. Now I'll generate a fleet-level AI report. The system synthesizes a batch analysis covering success rate, latency distribution, cost statistics, and hallucination trends. This report is designed for engineering leads who need a fast, executive-level snapshot of AI system health. Finally, I'll export the Datadog JSON configuration. This includes monitors, SLOs, and dashboards, allowing teams to reproduce the same observability setup directly inside Datadog with zero manual configuration. I'll now switch to the Datadog platform to show that everything you've seen is backed by real observability data. Here in Datadog, you can see all Sentinel LLM metrics, including global latency, hallucination drift, total fleet spend, and performance versus quality correlation. These charts are updating in real time from the same telemetry Sentinel LLM emits. This is a single pane of glass dashboard. It aggregates key signals into one operational view, including SLO compliance, active monitors, and anomaly trends. What's important here is that Sentinel LLM does not replace Datadog. It enhances it by adding AI-specific reasoning and automation on top of enterprise-grade observability. I'll now return to Sentinel LLM and switch the load controller to failure mode to simulate a safety issue. Immediately, you can see alerts firing in the SRE tunnel bridge. Rule 3 detects a safety guardrail block, indicating that a prompt or response violated configured safety policies. I'll ask the SRE assistant if any failures occurred in the LLM responses. The assistant explains that safety blocks are treated as logical failures and provides guidance on how to investigate them. I'll now generate SRE insights for this safety incident. Sentinel LLM identifies the root cause, explains why the safety filter was triggered, and generates a runbook outlining log review, threshold validation, and policy tuning steps. I'll briefly return to the Datadog dashboard again to show that the failure metrics and alerts are visible there as well, closing the observability loop between Sentinel LLM and Datadog. To conclude, I want to explain the SRE tunnel bridge, which is the backbone of Sentinel LLM. The SRE tunnel bridge is a high-resilience telemetry pipeline that securely connects production LLM applications to Datadog. It handles authentication, metric handshakes, log streaming, and event ingestion with minimal latency. When the bridge initializes, each metric performs a handshake and confirms ingestion with Datadog, ensuring no silent data loss. This bridge enables Sentinel LLM to continuously observe latency, cost, hallucination risk, token usage, and safety signals, while also triggering automated detection rules and incidents in real time. By combining this deep Datadog integration with Gemini-powered reasoning, Sentinel LLM transforms LLM systems from opaque black boxes into observable, controllable, and reliable production services. The full source code, architecture diagram, and deployment instructions are available in the GitHub repository. Thank you for this opportunity to build and demonstrate Sentinel LLM.